Compute the limit. Let's say that you are given this rational expression for limit as it approaches infinity. To solve this problem, the first thing you need to recognize is that the numerator, the highest degree is to the third, and the denominator, the highest degree, is to the fourth. So it indicates that the denominator's leading term, which is the highest degree, is greater than the numerator. So once you recognize that the denominator's highest degree is greater than the numerator's highest degree, the first thing you need to do is to factor out the leading term, which is the highest degree, for the numerator and for the denominator. So the leading term for the numerator will be x raised to the third power, and as for the denominator, it will be x raised to the fourth power times 1 divided by x to the third. Why do you times 1 divided by x to the third? Because x to the third right here cancels with this leading term, x to the third. So you're left with 1, which is the same thing as the given right here. That is 1. So you plus 6x divided by x to the third, so that the x to the third can cancel with the leading term of x to the third. You do the same thing for negative x to the third right here, but you times by negative 1. As for the denominator, the leading term is x to the fourth times 1, because x to the fourth times 1 is equivalent to x to the fourth as the given, plus 6x divided by x to the fourth. X to the fourth cancel with x to the fourth, so you're left with 6x. The concept is that for each of this term, you divide it by x to the third to make it the same thing as the given. Once you have that, once you factor out the leading term, it's time to cancel it. So x to the third divided by x to the fourth is the same thing as x to the third minus x to the fourth. So it will be right here. X to the third minus x to the fourth becomes x to negative 1. To get rid of the exponent of negative, you divide it by 1 divided by x. You put it on the denominator to make it positive. So the leading term right here will be x on the denominator. And as for this expression and this expression, it will be the same. Okay. First, now that you factor out the leading term and also divided it, as for this expression right here, you need to simplify it further. 1 divided by x to the third, there's nothing you can do about it. As for this one, x to the 6x divided by x to the third. So you take 1 minus 3. X to the first power divided by x to the third power, you could actually subtract it. So it will become x to the negative 2. To get rid of the negative exponent, you put it on the denominator. So as for this one, it will be 6 divided by x to the second. And this one's the same thing. As for the denominator, 6x divided by x to the fourth power, it will be x to the first power minus fourth. So it will be x to the negative third. To make the negative 3 positive, you put it on the denominator. So it will be 6 divided by x to the third. As for this one, it will stay the same because the numerator doesn't have any variable. So once you simplify all this, it's time to take the limit as it approaches infinity. If you take the limit as it approaches infinity for 1 divided by x to the third, it will reach 0. It's the same concept for this one. As for the denominator, as you take As you take the limit as it approaches to infinity for 6 divided by x to the third, it will be 0, and this one is also 0. So you're left with -1 on the numerator, and on the denominator you're left with x times 1 as it approaches infinity. So if you take the limit as it approaches infinity for -1, it will be -1, because anytime you take a limit as it approaches infinity for a constant, it will stay as that constant number. As you take the limit as it approaches infinity for x, it will reach positive infinity. And as you take the limit as it approaches infinity for 1, it will reach 1. So -1 divided by a 1 divided by a very large number, like to infinity, it will reach infinity. But the sign will be negative, because negative divided by a positive will be negative. So the answer for this particular limit will be -infinity.